Yeah, it's not really small, but it's gonna be really nice. But it's going to get about what else we can do, so it's not about time. Like 5 minutes, I still do. I still have. You didn't go.
Okay. Okay, so can you all download the question from the Brightspace? Previously, do you all have the makeup lesson face to face or online? I thought just before this there is a face to face. Okay, doesn't matter. Okay, so we are going to learn the transistor called device called transistor. It looks something like that. Okay, and one thing different is how many legs. You look at the diagram here. This is a transistor. How many legs does it have? 3. 1, 2, 3. So it's very different from what we learned previously, like your resistor, capacitor, or even the power supply. The voltage source only have 2 legs. Transistor have 3 legs. Okay, and then the symbol it looks something like that. This is the symbol of the transistor, and I also drew the transistor symbol on the whiteboard there. Okay, so can you all spend half a minute to read the question? Okay, half a minute to read the question, then I will discuss the question. Okay, so if you look at this thing, you have the V in is here, right? The transistor actually have 3 terminals. Okay, you all must know the name of the 3 terminals in order to do the calculation. So this leg is called base, then the other one is called emitter, and this one is called collector. Okay, you must know this one, and you must label the when you do circuit analysis, okay, like your EEF, you have to label the voltages and current when necessary. So for example, this one is a base. Okay, I just draw it here. Later on I need to erase, because of the limitation in the annotation software. You have the base, you have the collector here, and this one is the emitter, right? And when you label the current flowing into the base, the current always flows into the transistor. It doesn't flow up for transistor. Okay, the current always flow in. Okay, so this is called IB. Right? I stand for current. If you study EF, you know I usually stand for current. Then B, because this is a base. And then this current always flows into the collector. Okay, it doesn't flow the other direction. It always flows into the collector, and we label it as IC. Right? C stand for collector. And there is also a voltage called VBE. Do you see over here? VBE is given, right? So VBE is where? This is B, right? This terminal is called B. The other terminal is called E. So this is called VBE. Okay, and if you learn VBF, VEEF last semester, voltage have 2 terminal and has a positive terminal, positive side and the negative side. So the positive side has the arrowhead, and we are using double subscript notation. Okay, we are using double subscript notation. Okay, double subscript notation. I drew it on the whiteboard. You look at this one. Okay, this is what you learn in EF. So I will just do a quick review on this double subscript notation. Okay, for example, I write this one VBD. This is a double subscript notation, right? Because you have one subscript here called B. Sorry? Yes. I thought just now I mentioned already. So, class test. Yeah, class test will be chapter 5, chapter 6, and chapter 7. Class test. Then there's no exam. Okay, there's no exam. So next week very important. 10%. Okay, 10% is quite substantial. Huh? 10%. Why? 10%. Yeah. 10%. The module leader has put up an announcement. Okay, I think the module leader, did he mention the scope? Since you asked, now I remember one thing. His announcement, did he mention the scope of the? Yeah, okay, so you can see, the class test 2 he has already announced in the black space. Class test 2 is the scope is chapter 5, 6, and 7. Okay, duration 60 minutes, and is using the black space lockdown browser. So the format is very similar to your class test 1, right? Where you use lockdown browser. Also, the format is the same. Okay, let me see whether he mentioned or not. He didn't mention, but I think it should be either MCQ or multiple select question. And the test will start after the first 5 minutes of the timetable. I have no control. I have no control on this time. So please be punctual. Okay, please be punctual for the class test. Okay. So any question regarding the class test 2? 10%, quite substantial. And the scope still include the chapter 5 and chapter 6, even though you all will access on the mini project, right? For this chapter 5 and chapter 6. Okay, and please be punctual. The timing, start time and the end time is controlled by the system and by the module leader. I got no control. Okay. Okay, so just now I was here, correct? I was here. Okay, for the first question, you're just focus on my explanation. Okay. No need. If you want, you can jot down your own notes. You don't need to submit. Just focus on my explanation. The next question, then you need to submit. Okay. So I was talking about labeling the voltages and current. So you can see the question give you VBE, and because you need to do circuit analysis, you need to label VBE. Right. So that's why I was here. I say, okay, VBD. Let's say I say VBD. B is where? Is here. Is this node? D is the other node. So now let's say you have a voltage, you need to label it with the arrow, right? Like this red arrow here. How do you label? So you have the B and D line. So D is here, D is here. So you have arrow here. Where's the arrow here? Voltage has polarity, right? So when you write VBD, right? VBD, okay. This is the voltage, okay, and then you have the polarity, which is in this case represented by the arrow head and arrow tail. Where is the eraser? Do you all see eraser here? Oh, over there. Thank you. Okay. Okay, so now BBD, okay, let's say give you BBD, you draw the arrow. Where's the arrowhead? Arrowhead is at the B here. Why? The rule is the first subscript is the arrowhead. The second subscript is the arrow tail. So you have 2 points to measure the voltage. So sometimes we say this is a plus side of the voltage. Okay. So same thing. The VB here, we follow the same rule, right? The first subscript is B. Just now I mentioned to you, this is called the base, B, the base of the transistor. So when you label the voltage, the arrowhead should be here. Then the arrow tail is here. So you have the point B here and point E here, which is the subscript here, B and E. Okay, so it's nothing new. It's double subscript that you all have learned in your EEF last semester. Okay, next you have the VCE. Okay, VCE is also important voltage on the transistor. Same thing. This is a double subscript notation. You have the first subscript is C, so it's at this point C. The other subscript is E, which is the emitter of the transistor. Okay. Okay. Then next, you apply KVL, which is a loop via the base emitter junction. Okay. One thing I want to explain now. When you look at this transistor, you have the input and the output. Where is the input? The input is here. Okay, maybe I use orange. Do you see the in here? So this portion here is the input. Okay, this portion of the circuit is the input, and the output is here. The output is here. Okay, so you need to have some rough idea. This is the input. That means just to give you an overview, maybe I use white. You have the input here. You have the IB flow here. Okay, so normally this IB is a small current, but after going through the transistor is sort of very smart, very good. It will amplify the current, shows that IC is equal to beta IB. Okay, so this beta is normally like 100, 200. Okay, so this is the behavior of the transistor that you must know. Or I repeat again, basically this part here, the current input here, this is the input. Down here we have a voltage source, for example 5. Okay, so over here, this current flowing down here, this IC is the output. Okay, this side is the output. Okay, so when you plug in a small current here, the transistor will amplify the current, so that IC equal to beta IB. Beta is called current gain. Normally it's 100, 200, so it will amplify the current. Why amplify the current? Because you will use you need a large current to drive your load. So later on, in the subsequent question, you can see, for example, your load can be a light, can be a motor. You have a large current to flow through the motor so that the motor can turn, or it can be LED, which you will see in the next question. So why we need the large current? Just to summarize, because we want to drive a load that requires large current, like motor, lights, LEDs. Okay. So coming back to the question here. So that's why I write input here. Do you see I write input here? Because the loop is at the input here. And KVL is about loop line. So what I do is I will do a loop from the voltage source positive terminal. I do a loop. Right. I loop the loop will trace along the wire, enter the base, okay, come up from the emitter, and then where should the loop end? Based on the KVL rules, you must end it at the minus terminal. Okay, you cannot end it like maybe elsewhere. You should end it in the minus terminal. So this loop here, this is called loop. Okay, this loop sometimes, this loop and this current, they are actually different things. Sometimes it seems to be the same. So you apply the KVL, okay, using the KVL loop here. And next, how do you form the equation? How do you form the equation? After you do the loop, you will do something like B in, right? B in equal to the voltages along the loop, right? So now you look at this loop. In this loop here, how many voltages are there? You have one voltage for the 68K, then you have another voltage which is the VBE. So VE equal to 68K, the voltage at the 68K, plus the voltage VBE, right? This is a KVL which you have learned in EF, right? So you do a loop, right? Along the loop, you have two voltages, one here, then you add up. Okay, so I'm going to erase the annotation here due to the software, due to the annotation, due to the annotation software limitation. So I'm going to erase. If you want, you can take a photo for this loop. Otherwise, I'm going to proceed to show you the equation on the slide. Okay, so I proceed. So I erase the annotation. That is the software limitation. Okay, so this is a formula I wrote on the whiteboard just now, right? So I show you on the slide here, right? So V in equal to the voltage across the 68K. All right, this is a 68K. And then you have the voltage across the 68K, you use Ohm's law, right? So resistor multiplied by current, IB. Do you see IB here? Okay, so multiplied by current. And next, I have the VBE, right? The VBE is here. Any questions so far? So this is KVL. Okay. Any question? No question? Then let me ask you one question. Usually the student will ask me, they say, what about this voltage? What about this? You do the loop, okay? Okay, you do the loop here. Okay, this one is like you do the loop here. Then what about this point here? What about this point here? Okay, you do the loop here. What about this point here? Do you need to add in the voltage at this point? No, why no? Yeah, very good, very simple, right? Okay, sometimes when I was a student, I will ask because normally when we do KVL, we don't have a 3x terminal, right? But as long as you apply KVL, it's okay. That means you look at the this here in the loop only have this voltage and this voltage. It doesn't touch through C, right? So you don't have to bother. This is still KVL, okay? It's still KVL. The only thing is it's more advanced because it has three legs. The transistor has three legs. And then another way to just to elaborate more, you see this loop enter base come out from the E, right? And this B and E is taken care by this voltage VBE. So you don't have to bother about the C. Or another thing is this VBE is already taken care already. That loop enter here, come out from here, and then you have the VBE here. So you don't have to bother about the other C, the collector. Okay, so I come back here. So from this equation, we do the math. Okay, we do the math, right? So V in is given, right? VBE is given here, right? VBE is given here. So now you look at this equation, can you solve for IB? Can, right? Because one equation and there's only one unknown, which is IB. So you should be able to use mathematics to solve the equation. Okay. So you solve the equation, you get 23.5 microampere. So far, is it okay? So as I mentioned, this question, I will give you the complete solution. At the end, you can take a photo. If you want, you can just jot down some notes for your own. Okay, okay, so next, what do I do? Remember, I told you, once you have a small current flowing through the transistor, the output will amplify, right? The transistor will amplify the collector current. So this formula, we are going to calculate the IC, and this formula come in, okay? IC equal to beta IB or beta equal to IC divided by IB. It's the same formula, right? So IC equal to beta times IB, okay? This is a formula for the transistor. Then you substitute the value. So you can see beta is a very big number. You multiply by 100. It's given, okay? It's given in the question, 100. Okay, so you have 100 here. So you substitute 100. Then now we can see it has got a much bigger collector current. So in this example here, we can see that the transistor amplify the current. So the IC equal to beta IB. Okay. Okay. Then next, what do? We apply another KVL again. So now we want to apply KVL at the output. That means the loop will loop via the collector emitter junction. So I will do this. All right. So same thing. To do the loop, you start from the positive terminal. You draw the loop. Okay. So this is a loop, not current, although it looks like a current, but it's actually different thing. Okay. So the loop go in this direction. Go in this direction. Okay. So we go down. Go down, go through the resistor, enter the collector, and then the loop come up from the emitter. Then you should stop the loop until it reach the minus terminal of the voltage source. Right. Okay, so next, same thing, we have to write down the equation for this loop. How to build the equation for this loop? Voltage source, 5 volt. Right. 5 volt equal to what? Equal to the all the voltages along the loop. So you look at this loop, can you tell me how many voltages are there? How many voltages in this loop?
Five.
5.
I don't know.
In this loop, just along this loop, how many voltages are there? Okay. 1, 2, 3. How many voltages? 5 volt, excluding the 5 volt. 5 volt was already written here in the equation. So excluding the 5 volt, how many? 2. Okay, good. Why 2? One voltage drop is on the 1 kilo ohm resistor. Second one is VCE. Right. So I have the voltage drop across the 1 kilo ohm resistor plus the VCE here. Okay. Okay. So same thing. You don't have to bother about the base. Right. You don't have to bother about this point base because the loop doesn't pass through the base. The loop enter the C, and then you come up from the E, and this C and E is taken care by this BCE. Right. So I'm going to erase this notation. There's a software limitation. Okay, so 5 volt equal to the voltage drop. Okay, I repeat again. Basically, this is what I wrote on the whiteboard. 5 volt equal to the voltage drop across the resistor. Right. I don't draw this one. Across the resistor here. Then you have the VCE here. Right. So you have the equation come up. So far, any question? No, no question. Then you solve the do the mathematics. Okay, IC has is calculated here, so you just substitute. Okay. Then plus VCE. So now you look at this equation. Are you able to solve for VCE? Yes. One equation, one unknown. So you should be able to solve VCE, and then you get this answer. Okay. And then you get 2.65 volt. So far, is it okay? Okay, and maybe at this point in time, I summarize the 3 important. Okay, so actually, every time you do transistor for this module, there are only 3 steps. 1, 2, 3. Okay, there are only 3 steps. Okay, so there are only 3 steps. This is step 1, this is step 2, step 3. Okay. Later on, when you do the next 2 questions, basically it's these 3 steps. But sometimes the step will be in a different sequence. You will see that. Okay, so maybe I write down here. Yeah, 3 steps only or 3 methods. So you apply KVL. You do the loop via the base emitter junction. This is the input side of the transistor. And then the second one is the IC equal to beta IB. Okay, you amplify the current. And third one is the KVL. You look via the collector emitter junction, and this is the output side of the transistor. Okay, so this is the summary. Very simple. I mean, first time you see this, you may find it difficult, but later on you'll see it's always these 3 steps. Okay. Although the step can be in a different sequence, but it's always these 3 steps. Okay. Okay. Finally, you are asked to calculate VCB. Where is BCB? You have the C here, correct? You have the C here. You have the B here. So you have this equation. You have this equation, and then play around the equation. You will have BCB equal to BCE minus BBE, and we have already calculated VCE here, correct? VCE already calculated here, and the VBE you have is given by the question, 0.7 volt. Okay, so you will be able to calculate. Okay, I just want to explain one more thing on this so-called formula. Okay, this formula. Any question before I explain this formula? Okay, so this formula here. Is it the mic? Still have sound, ah?
Yeah, still have but okay lah.
Okay. This formula, either you memorize it or you can apply KVL to derive it. Okay. So this portion here, this circuit, I just focus on this portion. From this portion, you can determine the VB. Okay. So this is baseline. This is emitter. This is collector. Okay. And VBE is given, right? VBE. VCE is given, right? VCE. Okay, so VCE, okay, then based on double subscript notation, C is here, E is here, so you draw the arrow. C is the arrowhead, right? And we are asked to calculate VCB. VCB, right? VCB. So based on double subscript notation, how do you draw the arrow? Where's the arrowhead? Can you tell me? Arrowhead is it 1 or 2?
1.
1, good. Okay, so because the first subscript is the arrowhead. Right. Then next, how do you apply KVL? KVL is very powerful. Can apply on the transistor with 3 legs. Can apply just like that. Okay. So you can do this. VCB, right? VCB equal to what? So same thing. You do the loop. Maybe okay. I just use the red color. How do you do the loop? Start from the positive terminal. Alright, just like a voltage source. Start from the positive terminal. You loop from the positive terminal, and then where do you end? You end at the minus terminal. Now, so along this loop, what are the voltages that you need to add along this loop? VCE, right? VCE. Then you hit this one. When you hit this one, it's VBE. Okay, VBE. Plus or minus? Minus, because we hit the arrow tail first, minus. So it's like that. So KPL very powerful. If you cannot do this, you just memorize like that. Okay. Can okay. So if you want, you can take a photo. Okay, you can take a photo of this one. Okay, maybe I draw this one here. I got this diagram. Okay, this one I can draw here. This is the formula that I use KVL to derive. Okay, then. Basically, step 1, step 2, step 3. This one is sometimes there something extra. This one is something extra. Okay. Okay, take a photo. Second one, okay, can you take a full scan? Take up your full scan, and then you need to show me. For this one, I look at the other side. Okay, doesn't matter. You look in a different way, also can. Okay, I look differently. When I teach, sometimes I change. Also, this one I look from the BC, but it's still okay. This one I look from the BCD. Okay. Yeah, this is a tutorial question. Okay, tutorial 7. Okay, so this is a loop. Okay, if you want, you can take photograph. Otherwise, doesn't matter. Okay, this is a loop that I explained. Okay. Also, this is a loop at the input side, which correspond to this loop here. Right, correspond to this loop here. And the other one is output loop here, right? So this one correspond to this loop here, right? This is this loop here. Okay. Okay, Okay, so next question. Can you spend half a minute to read the question? This one, can you take out the full scan? Okay. Spend half a minute to read the question. So in the previous class,
When
on the turn out like that, 1, 2, 3.
I thought the door
Couldn't only.
no we had more.
Yeah, more. Yeah, more.
Then after that you all cannot take it anymore.
Not take it already, yeah.
Yeah, I think because the morning you all have assessment line.
Yeah.
Yesterday you all have assessment line.
Yes.
But the morning assessment went horribly wrong.
Huh?
People also
Sorry?
morning assessment went horribly wrong this morning.
Morning what?
Our morning test was so bad.
Yeah.
Very challenging.
One finish.
You all finish.
More challenging than my mini project.
Honestly, I expected so.
My mini project not. I mean, this morning assessment is more challenging than my.
No, it's actually quite easy, but there was not enough time for it.
Oh.
Yeah.
The whole was the mini project was 50% of this module, right? Our test for this morning, right, was 30%.
Really lying.
What module is that?
Engineering drawings.
Oh. Yeah, last time when I was a student, I like engineering drawing because I like to draw. Okay, so have you read the question already? Okay, so you roughly read the question. Okay, it says that it's a transistor that drives the LED. Do you see that this is look at this symbol without the arrows. This symbol is what? Diode, right? This symbol is a diode, right? So if you look at the this abbreviation LED, so D stands for what? Diode lah, right? It's a diode. Then LE stands for what? Like everything diode. Now everybody familiar. Maybe 5 years ago nobody know what is LED because now LED TV, LED traffic light, but everybody know already. Okay, so actually LED is a diode. DIODE is a diode. This is a special diode that can emit light when the current pass through. Okay. Then so this transistor have the current gain, which is 100, and the VCE is given 0.1 volt, VBE is given 0.7 volt. So for transistor, normally it's around 0.7 volt for VBE. Also, this one I will explain. Okay, I will explain later. We'll do all the calculation first. At the end, I will explain what is this MIN and the SAT. Okay. Okay. Yeah. Good. SAT stands for saturation. Later on, I will explain. Let's do the calculation first, and then okay. Down here, what does it say? The LED VF VF. Can you tell me F stand for what? So what you learn in the diode forward bias. Okay. Good. What you learn in the diode topic can apply here because it's a diode. So this it means that when the LED is forward bias, the forward bias voltage is 1.6 volt. And the current flowing through the LED, this is called the forward bias current, 20 milliamp. So what does it mean if, let's say, I try to plug in 90 milliamp to the diode? What is the possible? Do you think, okay, let's say, I'll just say 20 milliamp. And let's say I do a circuit such that only 5 milliamp flow through the diode. Do you think the diode can switch off with the light? No, so that's what it means. If you have a current less than 20 milliamp, let's say 5 milliamp flow through the diode, probably the diode cannot switch on, cannot forward bias, cannot turn on the right. Okay, so that is the implication. Okay, that's why it asks you calculate the value of RC to turn on the LED. Right? It asks you to calculate RC. Basically, it means that you want the LED to turn on when the transistor is switched on. Right. Okay, so you need to identify base, collector, and emitter. So can you tell me this one is called what? Emitter. Okay, because many years ago in the common test, common test include this chapter. The question didn't label E, B, and C. Some students memorized wrongly and then all wrong. Okay, it's just like during the common test, some students mix up the AND gate and the OR gate, they're all wrong. Also, basic thing you must know. So this one is what? Base, emitter, collector. Base, How to remember this is base? Okay, how to remember this is emitter? Emitter because it emits current. Do you see the arrow? this arrow is like the current flowing up, so it emit current. Okay, so that's why it's called emitter. Okay, how to remember is B? Because this is top, this is bottom, this is the base. Something at the center, very stable. So I remember it's at the base. And then this one is called collector, right? How to remember this is collector? Because it collects current. The current flows into the transistor. The transistor collects current. So this is called collector. This one, the transistor emit current, so it's called emitter, and this is a base. Basic thing that you need to remember. Okay, so same thing, you label the IB, all right? Because the current flows into the transistor, flows into the base, so it's called IB. Then you have this one, it's called IC, and then you have the VBE, usual one, and then finally VCE. Quite standard. Okay, quite standard. All this. Okay, so far, any question? Then next, we do, what do we do? We do step 1, 2, 3, right? Let's say we do step 1. Okay, let's say we do step 1. Okay, so let's do step 1. I use blue color. So same thing, I look from the positive terminal, come in here, and then this is the loop. Okay, I repeat again. This is a loop. Loop actually is different from current, although sometimes it seems to be the same as the current, but they are not. Okay. Okay, then I form the equation, right? Okay, I form the equation. Can we form the equation together? Where's my notepad? Okay. So I have the V in, right? V in equal to something like that's the equation, right? V equal to what? Oh, I erase the thing already. So maybe I use I have a slide with the loop. Don't have. Wow, I don't have. So that is the problem with the connotation software all gone. I don't have. Okay, I don't have, so redraw. Okay. Okay, so I redraw. Draw. Okay, I draw using the blue one. Okay, so the loop start from here, right? The loop start from here. Oh, yeah. Okay, there are some limitations with the software. Okay, so let's draw the thing. Okay, so I draw here. Okay, so you do the loop. Right. And this is called the loop. And this is called the loop. So I do a screenshot. Okay, so shall we set up the equation for this loop? So V in is written here. V in equal to all the voltages in the loop. So you look at this blue color loop. How many voltages are there? Look at this color. How many voltages are there? 1, 2, 3. 2. Okay, good. 2. So you have one here and another one is a VBE. Okay? Is a VBE. Only put 2 voltage. So I erase the notation. Okay, so I have the voltage. I have the voltage at the 10K, right? Okay, plus the voltage VBE, right? Right or not? Right, only 2 voltage, voltage at the 10K plus the voltage VBE. Any question? No question. So So I carry on. Okay, so I apply the 12 volt, right? Oh yeah, okay. I know what I want to explain already. Okay, look at this loop, Look at this loop. Can I do any calculation with this loop? If you carry on, okay. V is how many? Is it given? No, V is not given. And this part here, as usual, after that, the individual voltage, you apply KVL. So it's 10K multiplied by IC, right? Multiplied by the IB, correct not? Then VB, do we know? Yes. So VBE is given 0.7 volt in the question. So how many unknown are there? One equation, you have one equation here. You have one unknown, B you don't know, IB you don't know. So this equation cannot work. That's why I say, although we have 3 steps, sometimes this is not step 1. This one maybe step 3. So this step you cannot solve the equation, then you should do what? You should do the other loop, right? You have to try and error. Even myself, I also don't know. I have to try first. Cannot. So now I will do the loop at the collector emitter junction. Okay, let me erase away this one. Okay. Okay, so I do the loop at the collector emitter junction. Can you do it yourself? See whether you can get it. So you do the loop here, right? You do the loop here. Okay, then how? So let's do the blue color loop yourself before I give you the so-called partial solution. You go through the resistor, right? Then you go through the collector, right? Then how? Then you go back, right? Right. So can you set up the equation for this KPL loop? Okay, so how many, okay, in this blue color loop, can you tell me how many voltages are there? 3, apart from the 12 volt voltage source, okay. So apart from the 12 volt voltage source, we have one here, all right. The voltage drop across the diode. Second one, the voltage drop across the RC. Finally, VCE. So 3 voltages. You get it right. Okay, good. So you have this one. 12 volt equal to voltage drop across the diode. Right. The voltage drop across the RC and finally VCE. Right. Okay, 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 so so this one you take out of the equation, you should get 515 ohm. Okay. That's all. Okay, so you already got the answer already. Very good. Okay, so for example, after you do this is so-called the step 3. That was the step 3 in the last question, but now it becomes this formula, this KVL. Okay, so just now that KVL you have 2 unknowns, so you use this KVL, right? Then you use the formula here, or you have to try and error. Okay, it's really you have to try and error. Even myself also the same. So you try this one. Are you able to calculate something? Is IC given? IC is IF. Yeah, I didn't explain this one now. Okay. So to turn on the LED, IF equal to IC. Why? Equal to this 20 milliamp. because just now I explained already. If you want to switch on the diode and emit the light, you need to have this current 20 milliamp. So this is called IF, right? IF is here, right? Okay. IF is here. What is the relationship between IF and IC? Same, look at the circuit, because IF flow into the resistor and IF flows out of the resistor. So IC equal to IF, right? IC equal to IF. So IC equal to how many? IC equal to 20 milliamp. And are we given beta? Yeah, we are given beta. So one equation, there's only one unknown. You should be able to calculate IB, right? So if maybe I just walk around. That any question you can ask. What is the saturation? Yeah, I will explain after I do all the calculation. I will explain.
IP equals to 1 divided by B.
I see. Do you manage to calculate IB? Can Then the question asks for what? Asks you to calculate V in, right? Are you able to calculate V in? As I mentioned, there are only 3 steps, correct? We have done this one. The third step will be another KVL, right? Right. So if you do the KVL via the input, you should be able to calculate V in. Are you talking about this one? How you get IB? You just you have this equation, okay? Arrange just play around with the equation. You will get IB equal to IC divided by beta, right? Yeah. IB equal to IC divided by beta. Just rearrange the equation. Beta is given, so you should get 0.2 milliamp. Okay. So if you do the KVL via the base emitter junction, this part here, correct? If you do the KVL here, okay, if you do the loop here, okay. You should be able to get this equation, correct? Right now. Okay. Then you will have 2.7 volt. Okay. Yeah. It's good to draw the circuit. 能不能属于了哦？对。
Want to sleep with you. 要睡觉了，马上
I think okay. Who haven't finished? If I want to explain this MIN and the SAT. Okay, this MIN and SAT. Do you manage to get the answer here? 2.7 volt. Can If you have issue, raise your hand. I attend to you first before we proceed to explain this MIN. Okay, this MIN here stand for minimum. So this beta has minimum value and maximum value because the beta has tolerance. You can minimum maybe is 100, then maximum maybe is 125. One similar example that I think you all can understand better is, for example, you buy a screw from the shop, right? The shop say, okay, you say you want a 10 mm screw. Can you get exactly 10 mm? No, when the manufacturer will say, hey, there's a tolerance, right? There's a tolerance, maybe it's 10 mm, plus minus 5% or plus minus 10%. So same thing. When the manufacturer fabricate the transistor, they cannot guarantee you exactly 120 or what. They will tell you, okay, there's a tolerance, maybe minimum is 100, maximum is 120. So you have to read the spec. Or the manufacturer will give you the specification of the transistor. In electronics industry, this specification is normally known as data sheets or data sheets. Okay. Next, SAT stands for saturation. Do you see this one? Saturation. So the transistor, they actually operate in three regions. Okay, the three regions of the transistor, operating region. When you want to operate the three operating region, okay, so when you want to operate the transistor, the transistor can be operated in three regions. One is called the cutoff. Cutoff is very simple. For example, you look at this diagram. Let's say B is 0 volt. Let's say 0 volt, then no current flow through in the base current. Then because IC equal to beta IB, so no current flowing through the collector, then there will be no current flowing through here. For example, you cannot switch on the LED. So for example, it's B in equal to 0 volt. This is called cutoff. Right. Then second region, when you increase the B in to higher voltage, for example, maybe 2 volt, okay, you increase it to 2 volt, then you will have some current flowing through the transistor. Then you will have IC equal to beta IB, then you have a much larger current for IC. Right? So this is called active region. Okay. So example, what you need to do is you set B in to a higher voltage like 2 volt. Okay. And you operate the transistor in the active region when you want to amplify. When you want to amplify analog signal. Okay. Example of analog signal is your audio signal. For example, your mobile phone has speaker, right? The speaker can produce sound, right? In order to have a large enough current, audio signal, in order to have a large enough current to drive the speaker or your mobile phone speaker to produce the sound and music, you need to use, for example, a transistor to amplify the signal. And audio signal, they are analog signal. But analog signal means it's versus digital signal, right? Digital signal is, for example, 5 volt, which is 1, 0 volt is 0. Analog signal is like a sine wave. Can be 0.1 volt, 0.2 volt, 1.3 volt, 3.59 volt, that kind of thing. Okay, so the active region. Okay. And the third region is called saturation region. Saturation region. Okay. In the saturation region, what you do is V in is even higher. For example, in this case, 2.7 volt. Okay, when you have a much higher current flowing through the transistor VCE, okay, will go low to 0.1 volt. Okay, so this VCE at the saturation is called VCE saturation. Okay, and the behavior of the transistor is such that when you reach the saturation region, when you try to increase to let's say for this question, you try to increase to 2.8 volt, the transistor will still stay at the saturation voltage, which is 0.1 volt. That's the characteristic and behavior of the transistor. Right. For example, when I talk, I can talk loud, very loud, but there's a maximum volume that I can shout, right? Because of my capacity, the maximum volume is there. So same thing over here, the minimum saturation voltage, there's a limit, which is 0.1 volt. So which I mentioned to you just now. How much you try to come in more voltage for V in, it will still stay at 0.1 volt. For me also the same. You let me a lot, my maximum volume is like that, then it's like that. So this is called saturation. Yeah, so that's why you have the SAT. VCE when the transistor is operates in the saturation region. Okay. So actually for this one, there are a lot of things inside. Now I just briefly explain. You go back later and then you may still have some question. That happened to me also. Okay, but for this module, if you understand up to like that, it's okay already. Actually you go back and then you try to think more, and then if you have time, I think more you will have more questions. But doesn't matter. When I was a student, I also like that. Okay, so okay, so you can see in this question, the transistor operate in the saturation region. So now let's look at the next question. This one. Okay. Can you all spend half a minute to read the question? Do you see? It says that transistor is an amplifier. So when it's an amplifier, which region does it operate in? Amplified, all right. Amplified. So actually, it's operating in the active region, and you are given the beta as usual and the VBE and so on, right? Then you ask to. So take note, is actually operate in the active region as the amplifier. For example, to amplify the audio signal, to drive a speaker, and so on. Okay, so I wrote here, it's amplifier. The question says amplifier, all right? So it actually operates in the active region, and then and when the transistor is in the active region, this formula will apply. Okay, this formula IC equal to beta IB will apply. Okay. Okay, so as usual, we label the voltages and current. So you label the VBE and you label the VCE, right? IB is already labeled, IC also labeled. Okay, it's already labeled by the question. Then same thing, you have a 2 kVL, 2 possible kVL to apply, and 1 current gain, the beta, to apply. IC equal to beta IB, right? 2 kVL loop and 1 beta. Which one to do? You just try an error, and then you find that the equation has 1 unknown. You can solve, then you can use it. If the equation have 2 unknown, then you throw away this step and you try other step. Also, so in this case, you have to do the input first. I know you are that tired already, so I don't want to explain all the. I mean, that equation cannot work, that kind of thing. Okay, so you apply the KVL in the input loop. This part here. How do you apply the KVL in the input loop? Okay, where's the input? Can you all type? Okay, how to apply the KVL in the input loop? Go through the RB and VBE, then. Okay, so in case some students cannot visualize, it's something like that. Okay. Okay. This part here, 20 volt. Actually, if you can't see, you can extend the wire up, connect to a voltage source. This voltage source is actually 20 volt. Okay. Right. So if you want, you can extend the wire. You draw the voltage source. This voltage source is a 20 volt here. So this diagram, I draw the voltage source here. Then now I apply KVL. So from here, I do the loop here. Okay, then end here. Right. Okay, right. So if I do the loop, in this case, the equation will be here. Voltage source 20 volt equal to all the voltages along the loop. So how many voltages are along the loop? The RB and the VBE, right? So we have the RB. This one is from this resistor, and this VB is from here. So if you look at this loop, right? Inside this loop here, inside this blue color loop here, you only have this resistor, voltage drop, and VB. So it's here. Right now. Okay, so if you want, you can take a photo. Then I will switch back to my original slide. Okay, so the original is like that, without the voltage source, right? So you do, okay. So are you able to get 77.2? So in the electronics industry, normally we don't draw the voltage source for this thing. You know why? Waste time, okay. Yeah, true. Faster. And then normally a circuit is not just one transistor. It can be like 10 transistor or even 100 transistor. Then every transistor you draw the voltage source, the schematic diagram will be very messy. You draw so many voltage source and so many lines coming out from the voltage source. Okay, and do you know this mobile phone? How many transistors are there? Easily more than thousands of transistors. Okay, easily more than 1,000 more transistor. Okay, transistor can be very, very small. Okay. Okay, so you two KVL loop and one formula. So for my case, I use a formula because I'm able to solve for IC. Right. Oh, okay. Then I proceed to do the other KVL loop via the collector emitter junction. Then I have this. Okay. So if you have any question, you can ask me. Okay. So for example, do you know how to apply this loop via the output, which is the collector emitter? If you do it correctly, your equation for the loop will be this one. Okay. Yeah. Then let me see whether I have any more to explain to you. No more already, yeah. So the important thing is you understand the transistor. Okay, so objective, right? We have studied about the transistor. We understand the three legs. Which one is base, which one emitter, which one collector. We also understand the common voltages, VBE, VCE. And after that, we learn how to calculate the current and voltage by applying two KVL loops and one formula, right? And done. Okay, so if you're done, you show me and we can leave the classroom. And next week, remember, must come punctually because the class F2 timing is set by the module leader. It start 5 minutes. Okay? You read the announcement, it start 5 minutes after the lesson and then end at the state lesson time, which is punctual. I only need to mark this question 9. Okay, so it's 7.2 11.5 here.
Yeah, those are the I guess it's
Even on 5 feet and
Then the combo will find that they will can win. That's the only one for the actual final test and not actually. I'm saying everything You see that? Yeah.